Hey, everyone, it's Betsy here, and today we are solving quadratic equations by factoring. Don't forget the greatest common factor. Always ask yourself, is there something you can take out of all the terms to start with? So let's take a look at number one. Is there a GCF that we can take out? The greatest common factor. Well, let's look at the numbers, the coefficients first. We got a 2, and a 60. So look at the smallest number, 2. 2 goes into 2, 2 goes into 60. So I can take out a 2. Now let's look at the variable. It's an x. All three terms have an x, so I can take out an x. You always take out the smallest exponent for your variable. All right, what do we have left? Equals 0. Well, we got the 2 here. X times x squared is x cubed. Remember, when you multiply and the bases are the same, the bases are x's, you add the exponents. Now we're going to bring down the minus. All right, 2 times, well, we got the 2 here. X times x is x squared. Remember, that's like a 1 there if you want to put it there, if that helps you. Then we got to bring down our minus again. 2 times 30 is 60. And I've already got the x. So there we go. Now we've taken out the greatest common factor. So now let's go ahead and factor this. So I've got 2x. I've got a trinomial that I'm factoring. So we'll put my 2 sets of parentheses here. Now, all these problems are going to be factorable in some way. You will come across problems you can't factor, and that's when we get into the quadratic formula and graphing. Woohoo! All right, so we got to ask ourselves, what times what is x squared? Well, x times x is x squared. That takes care of this front here. Now the back has to multiply to 30. So what multiplies to 30? 1 times 30, 2 times 15, 3 times 10, and 5 times 6. But they multiply to 30, but they got to combine to get this -1 in the middle here, which means one of them is going to have to be positive and one's going to have to be negative. Okay, so to get a positive negative, we're going to subtract the two numbers to get -1. Well, 30 and 1, there's no way to get a -1. That's not possible. 30 minus 1 is 29. 1 minus 30 is -29. Gone. 2 and 15, 15 minus 2 is 3. That ain't going to happen. 10 minus 3 is 7. But 5 and 6, no, that's a different story. Think about it. If 5 minus 6 is -1 and 6 minus 5 is 1. So because the middle term is negative, you want the bigger number to be negative. So a +5 and a -6 will give you that -1 in the middle. Whew! We're all done factoring, but we're not done because we haven't solved this equation yet. Now, I want you to think about 0. When you multiply anything by 0, you get 0. And these terms are all multiplying. This is 2x times x plus 5 times x minus 6. So if any of those are 0, our answer will be 0. So I'm going to set them all equal to 0. So I'm going to say 2x, when is that 0? X plus 5, when is that 0? X minus 6, when will that equal 0? What would x have to be? All right. So 2 times what is 0? Well, 2 times 0 is 0, right? So x can equal 0. Because if I put 0 in here, I get 0, right? And 0 times anything is 0. How would x plus 5 equal 0? What would x have to be? I got a +5, so if I add a -5, I get 0. So x equals -5 will also get 0. So if this were -5, it doesn't matter what this is or this, we're going to get 0. And then the last one, x minus 6. Well, what minus 6 is 0? 6. X equals 6. And there you have it. There are your 3 places where your graph will cross the x-axis. Now, when I started this out, we had a trinomial to start, or a cubic trinomial to start with, right? So this was actually not even a quadratic when we started it. But the part where we factored into two binomials, this is a quadratic expression here. This is quadratic. And that's what we made into the two sets of binomials. All right, let's take a look at the next one. The next one right up front, we already know it's a quadratic because it has an exponent of 2, and that's the biggest exponent. So the degree is 2. If the degree is 2, it's a quadratic equation. Now, we always want to set it equal to 0. So the first thing we want to do is get everything on one side. So let's do that. 12x squared minus 4x. No, that's a positive 8. To move it to the other side, you make it a negative. That's the easiest way to look at it. So if you're going to move something, you're going to change its sign. All right, now when I look at this, I got to say, is there a GCF? Anything I can factor out of the whole thing? Well, let's look at our smallest number. Our smallest coefficient here is a 4. So when I look at 4, will 4 go into 8? Yep. Will 4 goes into 12? Yes. So I can take a 4 out. Now, they don't all have an x, so I can't take an x out. So that's all I can take out of there. 4 times 3 gives me that 12, and I got to bring down the x squared. Then bring down your minus. I already got the 4. 4 times 1 is 4, right? And then bring down your x. Then bring down your minus sign right here. And then 4 times 2 is 8 equals 0. All right. Now, we've got our GCF factored out. Now we've got to factor into two binomials, this quadratic. So I'm going to bring down the 4. I'm going to make my 2 sets of parentheses. And I know 3x times x is 3x squared. Now, remember the back numbers have to multiply to the 2 right here. So the back numbers have to multiply to this 2. So this times this has to equal 2. We know one has to be negative because a positive times a negative is a negative, but which one? If I put a negative, or let's put a positive 1 here, 1 and negative 2. I'm going to erase those little marks I put under if I can. There we go. There we go. So let's see if this works. So when I multiply the front, 3x times 3x, I get 3x squared. Now remember, to get this middle term, remember what you learned. You multiply the outsides, that gives you 3x. You multiply the insides, that gives you negative 2x. Well, is 3x minus 2x a negative x? No, so that doesn't work. So now we have to change our signs. Let's try changing our signs and seeing if that works. So instead of this being a minus and this being the plus, let's switch that. Let's make this the plus and this the minus. If that's the case, when I take this times this, I get a negative 3x, and 2 times 1 is a positive 2x. That will give me a negative 1. Negative 3 plus 2 is negative 1. So our factors, I'm going to write them up here again. We got 4 times 3x plus 2x minus 1. If you want to use the x box to factor that, you are welcome to. And we know that these equals 0. Don't forget, like I did, to put the equals 0. Now, we want to know what makes this 0. So I got to set everything equal to 0. Well, does 4 equal 0? No. So that 4 is not going to do anything for us. All it did was make factoring easier because we were able to use littler numbers. It was different up here because we had a 2x, and 2 times 0 is 0, so x could be 2, or 0, excuse me. Now, what makes 3x plus 2 0? And what makes x minus 1 equal to 0? Well, Let's solve it. That would be the easiest way to do it. So 3x plus 2 equals 0. I want x, so I'm going to subtract 2 from each side. When I do that, I get 3x equals negative 2. But I don't want 3x. I want x. They're timesing by 3, so what are we going to do? Yes, we are. We are going to divide both sides by 3. Boom. 3. And when we do that, I don't know why it keeps changing on me. 3. When we do that, we get x equals negative 2/3. And you can just leave your answer just like that. All right. And here, x minus 1 equals 0. Well, what minus 1 is 0? 1. Yes, so x equals 1. That's your other answer. So negative 2/3 and 1 are your answers. So if you were to graph this parabola, this quadratic equation, it is going to open up like a U, and it's going to cross the x-axis at 1 and negative 2/3. So 2 places it crosses the x-axis. All right, so your x-intercepts are 1 and negative 2/3. All right, let's go on to the next one. So again, the first thing when we're solving these equations, we want to make sure it equals 0. So let's do that first. Let's bring everything to the left. So we got 3x squared. That's a positive 12. So to put it on the other side, just make it negative. Equals 0. All right. Now, we can factor some stuff out of here. We started with a quadratic equation, but we got to factor some stuff out of here. So what can we factor out? 3 goes into 3, 3 goes into 12. They both have an x, so we can take an x out. What's left? Well, we got the 3. X times x is x squared. Minus, put your minus down there, 3 times 4 is 12, and we've already got the x on the outside. So this was a little easier, actually. Now remember, 3x times x minus 4 equals 0. So we want to know 3x, when does 3x equal 0? And when does x minus 4 equal 0? Well, 3 times 0 is 0, right? So x would equal 0 here. 0. Oops, that's not a very good 0, is it? My pen seems a little off today. 0. And then here, x minus 4 equals 0. Well, what minus 4 is 0? 4, right? So x equals 4. And those are your two answers. So if you were to graph this parabola, that's a regular U. And how do I know it's a regular U, actually? Because the coefficient, the number in front of the x squared, is positive. If it was negative, it would be a U facing down, an upside down U. Anyways, and where is it going to cross the x-axis? At 0 and 4. Those are your x-intercepts. They're your zeros. All right. Now, let's do our last one. Whew, one more, you guys, one more. We can do it. Isn't this fun? I love doing math. You know, math is beautiful. It's everywhere. All right, number 4. First thing we're going to do, yes, get everything on the same side of the equation. So I got 2x squared. Now, I want to put the x in the middle. That's a negative 9x, so I'm going to bring it over, make it a positive. If it's negative on one side, it's positive on the other. Minus 5 equals 0. There, we got everything on the same side of the equation, then equation equals 0. Now, GCF, is there a greatest common factor? Well, 2, the only thing that goes into 2 is 2 and 1. Well, 1's not going to do anything for us. So let's go to 2. Will 2 go into 9 evenly? No. 2 doesn't even go to 5 evenly. So we can't take out a greatest common factor. They don't all have the variable x, so we can't take out a variable. So right away, we're going to make our 2 sets of parentheses equals 0. Now, we know the first 2 have to multiply to the first one. So we got 2x squared. So 2x times x is 2x squared. The back numbers have to be -5. The only thing that multiplies the 5 is 5 and 1. 5 and 1. Now, remember, when we multiply these outsides and we multiply these insides, they have to equal a +9. How are we going to get that? We might have to exchange the 5 and the 1 and put them in the opposite spots, because the only thing that can go on those two spots are 1 and 5 or 5 and 1. Now, we know a positive times a negative is a negative. And since this 5 here is negative, one's going to have to be positive and one's going to have to be negative. So we've got a +9. Well, if I multiply 2x times 5, I get 10x. If I multiply 1 times x, I get 1x. Is there a way to combine those to get a +9? Well, a +10 and a -1 will give us a +9. So we need a +10, which we get from multiplying the two outsides, and a -1, which we get from multiplying the two insides. So there, we have got our factors. But we're not done, because what do we have to do? We have to find our x-intercepts, our zeros. So I'm going to erase a little bit here. La la la, la 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 la, make some room. I'm hoping that you guys, the factoring is coming back to you. And remember, if you want to use the X box, if that's easier for you, please, please do so. Now, when we look at this equation, it's the quantity 2x minus 1 times the quantity x plus 5. So if either of those are 0, 0 times anything will be 0. So we want to know, when will 2x minus 5, or excuse me, 2x minus 1. Oopsie daisy. 2x minus 1, when will that equal 0? And when will x plus 5 equal 0? Well, we know x plus 5. Well, -5 plus 5 is 0, right? So we can say right off the top over here that we want to know when that equals 0. So x will have to be -5. So when you go back and put -5 in here, you get -5 plus 5 is 0. 0 times anything over here is going to be 0. So -5 is one of our answers. Now the other one, let's solve it for x. We want to isolate x. We want to get it by itself. So we got to move that -1. It's got to go to the other side. How do we do that? It's a negative on the left, so just make it a positive on the right. It's like adding 1 to both sides. 0 plus 1 is 1. All right. Now, do we want 2x? No, we want x. That's 2 times x. I don't want 2 times x. I want x. They're timesing, so we're going to divide. And whatever we do to one side, we do to the other. These will cancel, and x equals 1/2. So our two answers are 1/2 and -5. If you were to graph this, again, our x squared coefficient is positive, so it's going to be a regular U, a parabola, facing up, and it's going to cross the x-axis at 1/2 and -5. Those are your x-intercepts. Ta-da! I hope this was helpful. I do plan on doing some more problems like this, for just maybe 1 or 2 problems instead of doing 4 on a sheet, maybe spread them out a little more. So there's more to come. If you need help, just let me know. Thank you.